function, and we're asked to find its inverse. So again, to find the inverse, what's the first step that we must do?
Swap the x's and y's.
Great. So the first step we must do is to swap the x's and y's. So here, this is my output y, right? So this is like a y right here. If I was to swap it, what would it look like? What would this function look like if I swapped the x's and y's?
Negative 9y.
So first of all, let's start here. What does a y now become?
X.
X.
Oh,
X
so,
is equal to,
the h in parentheses x always just means y.
it always means the output y, yes. Good clarification. So x is equal to, what does this now become?
Negative 9y.
Negative 9y
Plus 7.
plus 7 all over, what goes on the bottom?
6 plus 7y.
6 plus 7y. Okay? Is everyone okay with the first step? No math involved, no calculation involved. Just switch your x's for y's. So now what do we do after we have that? What do we do?
Solve.
Solve for y, right? You want y is equal to something, right? That's what you want, because that's going to be your f inverse, right? H inverse, right? So you want to solve for y is equal to something. So you want to isolate your y. Right now, y is upstairs and downstairs. So this is where I mentioned to you guys, some of the problems are going to be easy, like what we just did earlier, where we just had a linear function, and then we would just move things around by adding, subtracting, dividing. Now, this is going to be a little more complicated because we have fractions. So let's go back to our knowledge of fractions. How do we get rid of fractions?
Multiply by the conjugate.
Not multiply by the conjugate. So notice that this is x is equal to a fraction. This is what we call a proportion, right? So you can write divided by, what goes on the bottom?
1.
1. If you have a fraction equal to a fraction, what can you do to get rid of the fractions?
Cross cancel.
Right, cross multiply, right? So remember, proportions, it's a reminder, if you have a proportion is if you have one fraction equal to another fraction. How do you easily get rid of fractions? You cross multiply, right? You do a times d is equal to b times c, right? So this is something that we did in the beginning of the semester. How do we get rid of fractions, especially when you have a proportion? So here in this problem, it just looks uglier, but it's the same story. If I cross multiply to get rid of fractions, what do I end up getting?
6x plus 7xy.
Great, so first we multiply this through 6 times x plus 7y, right? Which, like you said, 6x plus 7xy, great,
Equals
is equal to
negative 9y plus 7.
negative 9y plus 7. Okay? No more fractions, right? So again, a review of what we've done in the beginning of the semester, which is how do you get rid of fractions? If they're proportions, then you just cross multiply, shortcut. All right, so now we want, what's our goal? We want to
Solve for y.
solve for y. So we want y to be sitting all by itself. So where are my y's at? My y's are here and my y's are here. I like to underline it to be, okay, where are you guys at? So if you want to solve for y, everything that has a y, bring it over to one side, right? So kind of like solving for linear equations, everything that has a y, bring it to one side, and whatever does not have a y, push it to the other side. So how do I do that? What am I going to do? I'm sorry? Minus 7xy, is that what you said? So you want to bring this over here? You could do that, but because I like it to be positive, what would be easier? To bring this over there or to bring this over here? Yeah, add 9y. But you still could do that. You could bring it here, but again, our goal is to get y sitting by itself, so we kind of want the positives. So we always want to ask ourselves, okay, what's going to be easier or going to look prettier in the end, right? So here's 7xy. I'd rather bring this guy over here to make it all positives. So here, as a result, I get 7xy plus 9y is equal to, what do I do with the 6x? How do I bring it over there?
Subtract.
I subtract it. So I'm going to subtract 6x on the other side, so I get 7 minus 6x. So now all my y's are sitting on one side of the equation. So this is, again, very similar to what we've done in weeks 1 through 7 of the semester, except these are it just looks more crazy looking. But it's the same idea. If you want to move things to one side, you add or subtract the opposite, right? And the idea is to gather all your y's to one side. So notice I have two terms with y's in it. I have two terms with y's in it. How can I get y to sit all by itself? I have two terms with y's. How can I pull out a y? What would that be called if I pulled it out? Factor. Okay, so dun dun dun. Now we're applying factoring. So next I'm going to factor out my y. Okay, I'm going to pull out my y from these two terms. So when I pull out my y from those two terms, when I factor it out, what do I get on the inside?
7x plus 9.
Okay, 7x plus 9. Does anyone have any questions with factoring? 7x plus 9, you could always double check by multiplying 3, you get that, is equal to 7 minus 6x, right? So I'm getting closer and closer to getting y sitting all by itself. That's my goal. Okay. And by the way, what you're doing here is very calculus-like. When I taught calculus, we did a lot of these, and there were a lot of students that were struggling with how do you get y to sit by itself. So you guys are really preparing yourself for more difficult math classes or for your next ones. So how do I get y to sit by itself? It's multiplied by this ugly coefficient. How do you get rid of a coefficient? Coefficients are things that are stuck together and multiplied together. How do you get rid of it? Not factor. You already factored it.
Divide both sides.
You divide both sides by the coefficient, right? So just like if I had 3y equal to 9, how do I get rid of the 3? I divide both sides by the coefficient 3, right? So same story here. Y is multiplied by this ugly coefficient. It doesn't matter whether it's pretty or ugly. All you do is divide both sides by that. So you end up getting y is equal to 7 minus 6x all over 7x plus 9. And that, my friends, becomes the inverse function h inverse x. So here, this becomes h inverse x. And that is the inverse function of h. All right, any questions? So in the last 4 minutes, which I'm not going to be able to do it justice, I'm going to talk about domain and range. So I'm going to tell you something. These are 4 boxes. If I know 2 of them, I can fill out all 4. And the reason why is if I have a domain of h of x, so whatever this thing is, if I have the domain of h of x, these are the x values of this, what am I going to know right away? If I know the x values of this, I will know the y values of the inverse. Right? So these two are going to be the same. Same story here. If I know, looking for my markers, no other color marker, okay. If I know my, say one of this, if I know the domain of this, guess what I'm going to know? The range of that. Right? So really, if you know 2 boxes, you can fill out all 4 boxes. So here they ask me, what is the domain and range of H inverse? So I want to know these 2. That's what they're asking me in this problem. So they could ask you domain range of anything. Well, we know that with fractions, right, here is H function and here is H inverse functions. So H function, well, let's start with this. H inverse, they're asking us for the domain and range. Here's H inverse. What can I never have in the denominator? 0. So you can never have a 0 in the denominator of a fraction. So 7x plus 9, what causes the denominator to be 0? So how do we solve this?
7x plus 9 equals 0. Divide by 7.
Right, x is equal to
Negative 9.
negative 97. So here, the domain of H inverse is that it could be any number except it cannot be what? X cannot be
Negative.
negative 97. So since I know that, I also know this. That was my domain of this one. I don't know how to find a range of this, but what I do know is I could find the domain of this. So this here is my h function. Here's my h function. The domain of this, what can I never have in the denominator?
0.
0. What's going to cause this thing to equal to 0?
-6/7.
So -6/7 will cause the denominator to equal to 0. So that means my domain is that I could have any number except for -6/7. Any number but that. So since this is the domain of h, this answer is also the same thing for the range of the inverse. So in your homework, though, on Alex, they asked you to write it in interval notation. So this is not in interval notation. I'm going to leave that to you guys to YouTube it or to look on Alex to learn how to write this in interval notation. We touched up on it on Tuesday, but it might not have been enough. So how do you write your answers in interval notation? Make sure to look that up.